Good morning. We are going to do indicator 13 today. And the learning target of this is I can find the area of trapezoids. For yesterday's lesson, indicator 12, yes, it was, writing formulas or solving formulas, but the learning target actually for indicator 12 was finding the area of triangles and quadrilaterals. So just want to make sure that yesterday you had understood that in quadrilaterals we had basically done all besides indicator 13's trapezoids, and we just wanted to break that apart separately so that you understand trapezoid as a complete unit on its own. And yes, you will be required to know the formula of trapezoids. Okay, and same thing with, we had done yesterday. We had done triangle, base times height divided by 2, because we talked about how there are two triangles in a quadrilateral. And then we had talked about length times width, for rectangles, side squared for a square, base times height for a parallelogram. All right, so trapezoids today. So when you think of the roof of the house, okay, these can be drawn in several ways. It can be drawn this way. It can be drawn this way. Sometimes you will see it sideways like this. Okay, these are all trapezoids. So a trapezoid is a quadrilateral with only one pair of opposite sides that are parallel. Okay, this is parallel to this is parallel to this is parallel to this one. So you can see that they are parallel. And so because if I take this, and we know that every quadrilateral is base times height, right? Height is always signified by the dotted line like this. So let's say this is my trapezoid and this is my base. But what if I took this same one and I flipped it over? So if I flip this one, guess what? This one becomes the base, so it could be either way, right? So that's why we have a small base. We have a big base and we have a little base, because if flipped over, the other one will become the base. Now, since both bases are not the same measure, okay, because both bases are not the same measure, we have to find the mean or the average of the two bases. All right. Now, in a parallelogram or in a rectangle or in a square, all four sides are the same. But the opposite sides, the length is the same, the width is the same. So it is, easy for you just to do length times width or base times height. But in a trapezoid, because the bases are different lengths, and because of that, we have to find the average of the two bases. Okay, so just think about your grades, and we'll talk about mean, median, mode, range in a later unit. But think about your own grades. In order to find average, you are basically adding all the test grades. Let's say you made 100, you made a 95, you made a 96, you made an 88. So basically, all four are added, and then it's divided by how many items are there. So this would be 4. And then when you do this calculation, that gives you an average. Okay. So same way over here, because we have two bases, we need to find the same for the top and bottom. That's why we are averaging it, so that we can do base times height. So literally it is base times height, but after the average of the two bases, if that makes complete sense. Because look, this plus this, and then I divide by 2, and then I do times this height. So as simple as that. So the area of a trapezoid, you're basically finding big base plus little base. Okay, average of these two. That's why, because there are two bases, we have to divide by 2. Okay, times, you can write it like this, or remember we said outside parentheses is the same thing, so times the height. So base times height, but because the bases are different measures, we have to find the average of the two, and that is why this is the formula for our trapezoid. Okay, now once again, please remember, all area is number of square units inside a shape, okay? And I had shown you the model yesterday as to why the square units and how those students had taken an area of 28 square inches, and they had put 28 squares in depending on the factors of 28. Okay, so 4 times 7, so the length could be 4, the width could be 7, or 14 times 2, or 28 times 1. So whatever the factors of 28 are, those are what they use to find the area of a triangle sorted out into those squares. But that is a different way that you can have the same area but different perimeter in this case. Okay. Now, let's go ahead and solve some problems relating to trapezoids now that you've understood why the formula is like this. So, very often in a trapezoid, you might be given, and I'm going to just use this example here. So let me just take this out and this out, and I will remove this one out. Okay, so you may be given something like this, and they may say, or let me make this slightly less slanting. Okay, and they may say that this is 11 inches. They may say this is 3 inches. Please don't go by what I've drawn over here, because of course the numbers are not written to scale. Okay, numbers are not written to scale. We are just doing some calculations based on if these measures are given to you. Okay, this is 7 inches, and then this is 8 inches, and this is 10 inches. Okay, now very, very, very important concept to remember when you are finding area of a trapezoid, of a parallelogram, as we've talked before. You always take the straight up and down line. We are never going to use this. We are never going to use this for area. And they will give you those extra numbers to confuse you. All right, or just to see whether you comprehend the material, that which numbers am I using in order to find the area. Now, we don't take the slant, because remember what I said, when you go to the pediatrician, you stand straight up. You don't slant like this to take your height. Height is not like this. It is straight up. You're standing on that scale to get your height. So remember that, okay? So in this case, let's do my area I know is the big base plus the little base. So I'm just going to substitute values. This is going to be 11 plus 3, okay? And my, obviously I'm dividing by 2, times my height, which is 7. Okay, so if I say 11 plus 3, I get 14 times 7 divided by 2. Okay, now remember fractions now. Anything from the numerator to the denominator can be simplified. So I know that 14 is divisible by 2. 2 divided by 2 is 1. 14 divided by 2 is 7. Because 7 times 2 is 14. And so now I'm left with just 7 times 7. So my area of this trapezoid is 49 inches squared as the final answer. All right, let's go ahead, solve one with decimals. And let's say I have a problem which gives me a trapezoid like this, and This is 13 and 4/10 meters. This is 7 and 2/10 meters. And this is 10 and 6/10 meters. Okay, so again, we're going to follow the same formula. Area is equal to big base. The big base is 13 and 4/10 plus little base, which is 7 and 2/10 divided by 2, because you're finding the average, times either this way or you can just write it here, times 10 and 6/10. Okay, please remember when it's again outside the parentheses with no operator in the middle, that means it's multiplication. Okay, so if I take 13 and 4/10 and I take 7 and 2/10, you know how to add decimals by now because we've done this. Okay, and x is 0 here, decimal under decimal, so same place values, please align. 4 plus 2 is 6, 7 plus 3 is 10, and carry over 1, so 20 and 6/10. Okay, so this is going to give me 20 and 6/10 divided by 2 times 10 and 6/10. Okay, now if I'm doing divided by 2, it's basically half of a certain number. So again, since this is fractions, I am going to go ahead and simplify because they are even numbers on the top and the bottom. I can divide by 2. So 2 divided by 2 gives me 1. 20 divided by 2 is 10. Decimal 6 divided by 2 is 3. Okay, or you can do the long division, doesn't matter, but this is pretty clear cut because half of 20 is 10, half of 6 is 3, and then you have the decimal in the middle. Okay, now what we're left with is 10 and 3/10 times 10 and 6/10. And so now all you're doing is multiplication, and this one, please remember, is very different from your addition. It's very different because in that you're aligning, but in multiplication, the most important rule to remember that you are supposed to count how many digits there are at the end and write that down so we know how many place values to move in at the end. 3 times 6 is 18, carry over 1, 0 times 6 is 0, plus 1 is 1, 6 times 1 is 6. When we go to the next row, we are going to put a placeholder, and then 0 times 3 is 0, 0 times 0, 0 times 1, 0. That is, again, remember the property of zero property of multiplication. Next place value, we're going to put 2 placeholders, so 1 and 2. And we have 1 times 3 is 3, 1 times 0 is 0, 1 times 1 is 1. Now we're going to add them all. Annex your zeros in all the blank areas. And we are going to go ahead and add 8 plus zeros is 8. Here's 1. 6 plus 3, 9. 0 and 1. Then we look at this, 2 place values. We start on the right and we go 1, 2. And so my area is 109 and 1800 meter squared. Okay, please remember once again, do not put the exponent, the square, above the number because then everything will be wrong. It is not 109 and 1800 times 109 1800. That'll be a totally different answer. So that is why either you write SQ units telling you it's square units, or you write whatever the unit is like meter, and then you write the exponent behind the units. You just want to make sure that you do not make that mistake, okay? Let's do a problem. In which there might be some missing dimensions, and then you have got to figure out what the answer would be, okay? Let me erase this. All right. So let's say I give you a problem. In which I have a trapezoid, and then let's say this is how it is, and this is 8, this is 14, this is 8, and then I'm given this as 15. All right? Now, the most important thing to remember, do not forget the missing dimensions over here. Okay, because if you forget the missing dimensions, your entire answer will be incorrect. Okay, so I have to figure out first, what is the big base? What is the little base? What is the height? Okay, so I can see from height, my height is 15. And if no units are given, in the end, you can just write square units or units squared. Okay, now, so I have this given to me. My big base is not just 14. Okay, this whole thing is the big base. So if the whole thing is a big base, all I'm doing is I am adding this and I am adding this in order to give me this whole thing is the big base. So 8 plus 14 plus 8 is going to give me the big base. So I have 8 plus 8 is 16 plus 14. That gives me 30. Okay, so this whole thing is going to be 30. Okay, and that is my big base. So this is 30. All right, then I look at, okay, I've got the big base. Now what would this be? So whatever in a rectangle, because look, this part is a rectangle, right? Opposite sides have exactly the same measure. So if this is 14, this is also going to be 14. All right, because it's a rectangle, opposite sides have the same measure. So therefore, this is my little base. So this is going to be 14. Now that I have my measurements, I can go ahead and I can solve this problem. So first step over there was to see what the missing numbers were or the missing side was, or to calculate the big base, little base, and the height. And next is now solving it based on the formula. So area is big base plus little base, average of that times the height. Okay, so we got big base is 30, we got little base is 14, and height is 15 and divided by 2. Okay, so 30 plus 14 gives me 44 times 15 divided by 2. Then I'm going to look from the numerator to the denominator as to what can I simplify, because we are talking about fractions. So I can see 2 and 44. Both are even numbers. So this is divisible by 2, I get 1, and 44 by 2, I get 22. So now I'm left with 22 times 15. And when I multiply that, 2 times 5 is 10, carry over 1. 2 times 5 is 10 plus 1, which is 11. Put the placeholder on the next row. 1 times 2 is 2, 1 times 2 is 2. Okay, so I end up with 330. Since there's no unit mentioned, you would write unit squared. All right, so this is how to find the unknown sides or the bases, and then to calculate that. So let's do one more problem like this, And I am going to erase this over here. And I am going to draw this out. Okay. So this is a trapezoid also, because remember, this is not the same, the slant. And then these two are parallel but not the same. Okay. So let's say I have 6 feet here. And I have 8 feet here, and I have 16 feet here. Okay, so now when I look at this, I need to figure out, okay, what am I missing? Do I have a big base? Do I have a little base? Do I have a height? Okay, so if I look up, I have the smaller base, which is 16 feet. If I look here, if this is 8, this is also 8 because it's a rectangle. Okay, because it's a rectangle. So my height is 8 feet. And then the base, the big base, obviously cannot be smaller than the little base. Okay, so be careful with this one, because very often you forget to add, because 6 feet is only this much. Okay, but we are doing this part also. This is a rectangle. So if this is 16, this is also going to be 16 feet. This part. Okay, and now this whole base, the big base, would be 16 plus the 6 to give me the big base. So 16 plus 6 gives me 22 feet. Okay, so now I have my measurements. I am going to erase this. And I am going to apply those numbers over here. So all you're doing is substituting the values. Big base is 22. Little base is 16 times height, which is 8, and divided by 2. Okay, so 22 plus 16, 6 plus 2 is 8, and 1 plus 2 is 3, is 38. Times 8 divided by 2. Now you could have simplified any one of these over here because both are even numbers. Let's say I choose to do 38 divided by 2, I get 19. And then when I multiply 19 times 8, I am going to get 152 square feet as my final answer. Okay, so trapezoids again are really easy and they are fun. Just remember, it's actually exactly like any other quadrilateral where you're doing length times width or base times height. But the only reason we have an additional step in which we have to divide by 2, because both the bases are a totally different size. And so in order to make them into the same size so I can do base times height, I have to find the average of the 2 bases. All right. Well, that was areas, and we've done let's see. In indicator 12, we've done triangles, we've done rectangles, squares, parallelograms, and then this is the last one before we go on to composite figures. All right. Have a nice day, guys.